Hi everyone. This is an example on manipulating an expression that has a messy expression that has units in it. So we have a formula already set up for us that's supposed to give us the body surface area of a baby who's 50 centimeters long and weighs 3.5 kilograms. And it already has told us that this is supposed to be in square meters, but I'd like to walk through and see that work out in this calculation. So I see a couple things. I think I'm going to kind of mush together the top and the bottom. So first thing on the top, this is all considered multiplication, so we can snag that 50 and that 3.5 and we can squash them together. So 3 times 50 is 150, and we need half of 50, which is 25. So we've got 175 kilometers times kilograms on the top. And then in the bottom, I just want to make that a single fraction. So I'm going to consider this 3,600 over 1, and the dash in units is means multiplied. So you can just put a times in there, but you'll see that a lot. Things like foot-pounds and Newton meters, man-hours, I can't think of any others right now. Those all get the dash, and that means that those units are multiplied. Okay, so just one step in so far. So I am dividing by a fraction. I think the next thing I'm going to do is rewrite that as multiplication by the reciprocal. So I'm going to multiply by, and you can put a 1 down here if you like that better. 1, my pen's not working, meter to the 4th divided by 3,600 centimeters times kilograms. And that's still all under the square root. Okay, so I'm finally looking at this thinking I see some cancellation that can happen. The centimeters times kilograms is going to cancel from the top and the bottom. I'm going to think about this first one as being over 1, so I can multiply across, and I'm left with 175 meters to the 4th divided by 3,600. Okay, in general, I'm okay with getting a decimal approximation as an answer to word problems. I'm going to go ahead and keep it exact here just because it's really good practice. Some of the stuff we're working on in Chapter 1, and you'll see a little bit of that inconsistency. There'll be things in the homework where I ask you to keep it exact. And don't stress about it. I'll try and be really clear. You can always ask, but I just want you practicing both things right now. So in this case, I know that square roots can be split up over multiplication or division. Roots and exponents play nicely with multiplication and division, not true with addition and subtraction. So I'm going to mentally break this up and say, okay, well, I can split up the root 75, the root of meters to the 4th, and the root of 3,600. Okay, so 2 of those are really nice. The square root of m to the 4th is m squared. If you're not seeing that, meters to the 4th, we're raising it to the 1/2 power. Square root is the same as a 1/2 power. And our exponent rule says multiply powers. So 4 times 1/2 is 2. On the bottom, 3,600 is actually a really nice number. If it's helpful, you can split it up mentally as 36 times 100. Square root of 36 is 6. Square root of 100 is 10. 10 times 6 is 60. The 175 is not a perfect square, but 25 is a factor of that. So I'm just going to go ahead and make one step towards splitting that up. 25 times, ooh, am I lying to myself? I'm totally lying to myself. It's not times 5. I think it's times 7. So last step, I'm going to split up that root 25 and root 7 and say root 25 is 5. And, oh, I guess not quite last step. I'm going to go ahead and split off the meters squared so they're not in the fraction anymore. Same meaning, but it looks a little prettier. And I do see one last thing I can do. I can reduce the fraction. 5 goes into 60 12 times. So I have root 7 over 12 square meters. And again, generally for word problems, decimal answers are great. They're easy to make sense of. I encourage you in chapter 1, when you have something reasonable to simplify, to practice the simplification. Okay, thanks for watching.